Friends, we will continue the problem in the limits topic. Another problem, right? Show that limit z tends to infinity 2z cube minus 1 divided by z square plus 1 is equal to infinity. Now, how will you prove that here? Proof of this or answer for this here? Now, proving the problem of such type, that is to prove that general way, prove that limit of f of z as z tends to infinity is equal to infinity. Now, you observe that limit is also given infinity, answer is also given infinity. In this case, it is equivalently we prove that what? Limit z tends to 0, 1 by f of 1 by z is equal to 0, right. So, observe this, the another pattern here, equivalent form which is equal to 0, that is 1 by infinity is 0. So, I am take left hand side of this here, right here, limit z tends to 0, 1 by f of 1 by z, that is limit z tends to 0, 1 by the function, and how you have to write here? See this, wherever you have z, it is 1 by z you have to write. So, reciprocal 1 by 2 into here 1 by z cube, that minus 1 divided by 1 by z square plus 1, okay, clear, right. Now, that is equal to here, let me write here, right. So, that is equal to, on simplification, limit z tends to 0, which is here, you take simplify this, okay, means taking out LCM here, 1 by 2 into 2 minus, so z cube is LCM there, it is going to be, yes, z cube divided by here multiplication, nothing but you have got this here, it is z square, okay. So, now this on simplification what? It becomes here, so z square and z square you can cancel out that, here it is, what becomes here? Limit z tends to 0, it becomes here, see denominator to denominator goes to numerator, say z square divided by, it becomes what there? See here 1 remains, 1z remains here, this 1z or z cube, z square, 1z remains, and that z goes to where? It is numerator, this joins, 1z joins with this here. If you want, I will show you one more step, it is equal to here 1 by, so it is 2 minus z cube divided by, as I have told here, 1z remains here, z into what becomes here? 1 plus z square. So, this is equal to this here, now this becomes here minus 2z cube, that is equal to, you apply the limit there or take the limit, as z tends to 0, this is 0, therefore 0 into 1 plus 0 divided by 2 minus 0, what is it becomes? Numerator is 0, denominator is 0, so 2 there, therefore answer is what? It is equal to 0. So, you have justified the result equivalently, proving the given problem, it is infinity is equivalently proving equal to 0, you have got the result, okay. So, these are the 3 different varieties of limits forms you are observing in the 3 different problems here. Okay, one more, as you have defined the function, this is by direct definition you have got that. Now, you have also observed the taking out the limit in the epsilon delta definition. Let me take one example how to find the limit using epsilon delta. See, prove that, see the directly problem is given, prove that limit z tends to infinity 1 by z square is equal to 0 by using the definition, by using the epsilon delta definition. Now, how to find by using this here? Proof of that, here it is. Now, as by the definition, we know that by the definition here for a given function that for a given epsilon greater than 0, that if there exists a number delta greater than 0 such that modulus of f of z minus w is less than epsilon when here mod z minus z naught is less than delta. That is what? That is nothing but here it is. This is nothing but what? Limit of f of z as z tends to z naught is equal to w, right? By using this notation is equivalently or equivalent transformation in terms of epsilon delta definition here. Okay. So, now here what is given here? For your convenience sake, I will write here f of z is equal to how much? 1 by z square, and w is equal to what? It is equal to 0, they are given here. You go and substitute here and find a suitable delta so that this is less than epsilon. So, in this case here it is, or here it is, z tends to infinity is given here. Now, we will prove this here as z tends to 0, that is nothing but here as z is nothing but here it is greater than 1 by delta, or z is less than delta means what? 1 by z is greater than delta. You keep this is in mind equivalently. So, now mod f of z minus w is equal to here nothing but 1 by z square minus 0 less than epsilon whenever here it is z is less than what is here it is less than delta, or less than z naught is less than delta. So, that is nothing but here mod z square is less than epsilon. That implies here 1 by z square is less than epsilon, or that is interchanging that here it is 1 by epsilon is less than mod z square, or that is mod z square is greater than 1 by epsilon, or that is nothing but what? Mod z is greater than 1 by what we have got here it is plus or minus, or we will say it is epsilon is always positive. So, root epsilon. So, that is nothing but what? 1 by, you take root epsilon is equal to delta. So, taking that here it is take root epsilon is equal to delta, therefore, mod z is greater than 1 by delta. Therefore, whenever you have taken the value of that z is 1 by delta, then the limit of the function tending towards to 0. That is the way you are going to justifying the limit of the function in this way. Okay. Thank you. We will continue in the next class some more problem.